Thanks for coming, everyone. I think we might need to turn that light off. It's a little hard to see. Unfortunately, builds.io uses a dark background. I've searched everywhere to figure out how to change this. As well as it looks like it's just out of focus, huh? Okay, can you guys in the back kind of read that?
A little fuzzy.
There's some seats up front too.
So I apologize. However, all code and examples and everything are online. Let me just do a quick test of something real quick. So while I'm doing that, I'll give a background on myself. I'm Cameron Owens. I like to do a lot of maker, hacker type of stuff. And about 6 months ago, I was like, hey, Dave, we should get a group together that meets up and builds stuff rather than like just coming out every Tuesday and letting everybody's eyes glaze over. Why don't we actually build something? And he was like, great, when are you going to start it? So that's how this kind of got started. I wanted to get people together to kind of do hands-on-y type of things and say, hey, like, I can be empowered to do stuff. So my day job is I work for Applied Materials, software developer. So I get paid to play with robots, which is pretty cool. But in my free time, I like to do stuff like this. However, when I get pretty busy, so sometimes I forget, like, oh, where did I put that code I wrote or something? So I'm trying to find a couple things and modify some code. So today we're going to be talking about the particle photon, which is a great piece of hardware and everything. I like it a lot. And one of the things that we're going to be playing around with is a messaging library called MQTT, which is, if anybody is not familiar with it, we've talked about it in the past, but it's a message library that allows for really easy data communication between two different points, i.e. through a client and a broker. So, quick raise of hands, has anybody ever done like WebSocket programming or message programming? Okay, so a couple of you, so you'll be kind of familiar with it. So a good way to think of it is that MQTT is like WebSockets. Basically, you have two endpoints and you say, hey, I want you to send a message over to this person.
I'm sorry to interrupt, but can you talk about the photon itself, like what it is and what's the difference between the Arduino and the other chips that are available out there?
Yeah, so, hold on one second. That is a very good question. So the question that was asked is what is kind of different than the particle photon? So the photon is very similar to a lot of your microcontrollers that you may be more familiar with that are out there, like the Arduino. But one of the things that really makes it different is that it has a built-in Wi-Fi chip. And it's running an ARM core, so it's a pretty powerful microcontroller that has built-in Wi-Fi. So retail for just the development board, which is the particle photon itself, it's going to run you about $20. And when you compare that to other things, you may say, whoa, that's pretty pricey, that's expensive. You know, why would I pay this much for it? Well, there's a lot of great support on the back end, a lot of great web interfaces that the build.io group is doing that make development really easy. So the particle photon is one of a couple microcontrollers that I play with that have built-in Wi-Fi. Another one that's really popular is the Node MCU, which is pretty much the same exact thing as a photon. It's a bit different, but with that you don't have any support. It's all community support. It's kind of like Windows versus Linux, right? Windows, you know who exactly to go to if you have problems. You can go to them. Whereas the Node MCU is kind of like Linux. It's an open source thing. Go figure it out yourself. So we decided to go with Photon just because it's pretty easy. They also have a mobile app, so you can do some things with it, and all kinds of stuff like that. It just makes it easy. So yeah, the particle photon has built-in Wi-Fi. I don't remember how many digital pins. It's like 9 digital pins, a couple analog pins, and that's about it. So it's really designed for Internet of Things applications, really development. So if you were to, say, design your own hardware, then you'd go to the particle.io people and say, hey, I want 1,000 of these chips, and then you're going to be paying like pennies on the dollar for the chips. So really, when you buy the development board, you're really buying their support for a lot of things. So today we're going to do a couple examples. Last workshop that we did, for those of you that weren't here, we set up our particle photon using the mobile app and got it connected to the Tech Shop Wi-Fi. And then, what did we get after that? Did we just do blink and LED?
Blink, yeah.
That was about as far as we got. So we'll kind of cover a couple of those things, but not too much. Today we're going to dive into some of the things that we've done previously with the Raspberry Pi. We're going to set up the particle photon as an MQTT client, so it'll be publishing to our broker various sensor bits of information, and then on our broker side we'll be reading those messages. So for those of you that aren't familiar with a lot of our code development, everything that's on a microcontroller we typically do in C, C/C++/wiring the whole Arduino stuff. So if you've written code for an Arduino, this code will look familiar. But then everything that we do on our broker is typically in Python, higher level language that's really fast and easy, and I love it. So for those of you that didn't attend in the past, if you want to go back and take a look at stuff, if you go to AustinIoT.com and then to our workshops, I will send Dave the transcript from last time.
That needs some work, sorry.
Yeah, not a problem. I do everything through Google Drive, and so there's this guide that will get you started, kind of talk to you about microcontrollers, getting everything set up. So the purpose of this is to provide open source information for people to get started. It'll show you how to get all of the tools installed on your computer, yada, 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 et cetera, et cetera, et cetera. So let's get started. So I'm going to start with the assumption that all of you guys have your photon connected to the Tech Shop Wi-Fi. Is that a safe assumption?
Yeah.
For those of us that have them? Okay, so mine's connected.
Unless you want to show that procedure that you go through.
Does anybody want to go through that?
Yes.
Okay. We will blaze through this real quick. So setting up your photon, there are 2 primary ways to do that. They really like to enforce you to do all of your connection via phone. So if you are on Linux, this is one of the main ways to do this. I found the Atom editor. If anybody's familiar with the Atom IDE, it has an extension to be able to do photon development, but you've got to go get Docker and a whole bunch of stuff that I haven't documented yet. But it works well, but it's just hurdles. So we'll go over the mobile device setup first. So what you're going to do is go to your mobile device app store, get the Particle app, which will look something like this depending on what you do. I'm on Android, so it's the same on the iOS store. And so you go, you install the app. The app is free. Service provider data charges may apply. And so you download that. Now, are you using Linux by chance or Windows? Windows, okay, cool. You are perfectly safe, so just ignore all of this. So while you're downloading the mobile app, what you'll want to do is connect your particle photon to power. And you're going to hold down this button right here. This is the setup button. So if you're looking at the power connector, it's the one, depending on your orientation, it's just this one that's on the same line as the antenna connector. And you're going to hold that until it flashes. It'll flash blue really fast, and then it'll just kind of go to this constant strobe. So then, by the time you've done all of that, you should have the app installed on your phone, and you'll either create a builds.io account, or if you already have one, you'll just chug in your information. All it does is just takes your email, and that's it. So then once you've created your account and you've set it up, you're going to click on this little plus icon and say, hey, I want to set up a new device. And then you'll want to select set up a photon. What this will do is it turns your phone into a bridge. So your particle is hosting its own Wi-Fi network. Your phone's connected to other data network connected to the web. It will then act as a bridge to there and go and get the firmware for the photon and make sure everything's copacetic. So you have to have an internet connection for this step to work. So then it'll connect to it. You'll see some colors flash on the photon, and then it'll be connected to your account. The other thing, part of this is that so Particle has an IDE that's online. Which is kind of cool in my opinion. So as long as your photon is connected to the web anywhere in the world, you can reflash it as long as you're connected to the web as well, and you don't have to physically be there. So it makes firmware updates really nice. So one of my projects that I do is I have an internet controlled flower pot. So let's say I'm like, oh, this would be a great idea to do my data collection on my flowers. While I'm at work, at lunch, I could hop on and upload something, change the firmware, and not even physically be there. So you'll need to then go to, through a web browser, go to build.particle's webpage and log in so that you can start writing your code. And that's going to be the primary way that we'll interface with everything. For those of you that like to do things through your desktop, or through your laptop, there is this IDE called the Atom Editor, and I'm kind of a fan of it, the more that I play around with it. It requires some Docker stuff, that's how they transport all of their packages and stuff. Yeah?
What was that website again?
Builds.particle.io. And that'll then take you, and you'll log into your account where you'll store all of your firmware code files and all of that. So if you prefer to do things directly just you want all of your code locally on your computer, you don't like the idea of somebody potentially having access to your intellectual property, then you can also use the computer side IDE. And to do that, you'll come here to not packages, what was it? It was, it should be under packages. Console. Yeah, you'll have to go to the console, toggle off the console, and then do a JavaScript recipe. It's like an npm install photon-CLI. They have it documented on their webpage. I think I covered a bit of it here as well. But you can then go get the packages. Oh yeah, particle/dev complete. And I'll go and get it, and then you'll log into your Particle account, and then I'll connect you. Similar instructions for those running on Mac OS 10 or Windows. Any questions on anything? So getting up and running is really easy. If you've done anything with, say, an Arduino, it's not much harder than getting set up with an Arduino. I'm going to take this link for those that are interested and publish this on the meetup page. So for those of you that want to pull that up and read at your own pace, you're good to go. Okay, so let me splash this guy. Okay. Excellent. Okay, so let's get kind of started. Is anybody not? You guys are already connected to TechShop Wi-Fi with your photons, right?
Yeah.
Okay, so the first thing that we're going to do is a real basic MQTT publish subscriber, and we'll walk through the code on this. So this is all written in C. As you can see, it uses the .ino sketch format. It's basically Arduino stuff. I don't know why they call it an app. It drives me nuts. It's firmware. Your application's bigger, but they call it an app. So if you go to build.particle.io, you should be presented with something like this when you log in. So what you'll do is you will create a new app, which will then give you a blank editor. I have all of this code uploaded to my GitHub as well. So if you go to Candid Cipher, then the Austin IoT Workshop repo, and then Workshop 6. I've got the door sensor motion, and then the particle, the photon color. This is what we're going to be playing with. So the walkthrough of this code is the first thing that we do is we include the MQTT library. So you don't need to, because everything's done on the web through the web browser, unless you're using the Atom IDE, it'll go and fetch these header files. They're already part of the libraries for the photon. So it'll include all of the libraries and the tools that you'll need for this. The next thing that we do is we set up a character byte string for our broker, which is just whatever our broker's IP address is. So for my system, if you want to subscribe and publish to my MQTT instance, I am running at 10.11.17.140. So if you guys want to connect to my MQTT subscribers, you can see here at the bottom. Let's grab this. So this is the message that is sent to the published or to the subscriber. So this is a message that was published by the photon to my broker, which is subscribing, saying that hey, it joined the system. Okay. So you will just plug in the IP address of whatever your broker is, and then so with MQTT, it is a publish-subscribe model. So you have a published topic. Topics are delineated or separated by the /. So this is the topic hello world, and then the client is subscribed to this color topic. And we're going to be controlling the RGB LED on the photon. So we'll send it messages to change, what color the LED is. The next thing is then we create an instance of this MQTT client class, and we pass it in the broker, which is just the IP address. So if you want to take this out and hard code it, you can do that, that's fine. This 1883, that's the port that the broker on my computer is running. And then we link it to a callback function. This is a function that's called whenever a message is sent to the subscriber. So here we have our callback function, which takes a character byte string of a topic. Then it will then also take in a payload, so whatever the message that was sent to it is its payload, and then the length of the message. So basically, we just kind of decode this message, and so we copy it to memory, and then we then do a string comparison. So if the message is red, we write an RGB value to the LED of 255,000, which is red, green, blue. So the red LED is fully on. If it's green, the green LED is fully on, and the blue LED is fully on. Else, all three values of fully on produces white light. Quick question, has anybody ever used an RGB LED?
Just the one that's included on the
Does anybody not know how an RGB LED works?
Be cool to explain it.
Okay. An RGB LED is really 3 LEDs built into one. No, I just want to. Okay. So traditionally, you have an RGB LED, and this will have a was it an anode or? Yeah, an anode, positive, right? Anode's positive, cathode's negative.
Yeah.
Okay. The internet trolls will crucify me for that. But yeah, so you have 3 anodes, which is your red, your green, and your blue, and then you have a common ground. So this is a great schematic because it actually shows all 3 diodes in here. And the way that an RGB works is you turn on each of these these LEDs, these diodes, to a certain amount of voltage, and it will then give off that much light. So whether it's your LCD or some other LED system that has an RGB LED, that's essentially what's going on here. And so in that code where we say we will write a value of 255, that is using the 8-bit analog to digital, or the digital to analog converter within the microcontroller to write a full 3 volts to the red, or a full 3 volts to the green, or a full 3 volts to the blue, or any combination thereof. And so what's going on is it's taking an 3 volt signal, breaking it up into 255 segments. And so let's say you wanted the red to be halfway on, and the other colors fully on, to kind of make a pink, or actually, to do pink, you would want like red of like 180, and then the other 2, I don't know, maybe like 60 or off, maybe, to make a dim red light. So you can play around with those things. Oh, can you hear me now?
Cathode is positive, anode is negative.
Okay, so you have 3 cathodes and 1 anode for common ground,
Okay,
basically.
and amazing.
So, Cameron, I have a quick question.
Yeah.
If you give like a red value, let's say you're doing like 128 instead of 255 or whatever it is, are you giving it a different voltage, or you just use pulse width?
You're using pulse width.
Okay, gotcha. It's it's abstracted in the library, is that right?
Yeah, so it's using, it's basically abstracted. So what we're doing is we're using the rise time of the voltage on the output to simulate a 3 volt, or a varying voltage. But really what we're doing is we're just turning 3.3 volts on fast and then turning it off. So then the average voltage over time results into, say, like 1.8 or something.
Huh. Cool.
So yeah, within the code, they basically abstract all of this for you. Let me go back to the GitHub stuff. They abstract it for you, so you don't have to determine like what your duty cycle is, or what, essentially that's what you're changing your duty cycle is, of the value. It'll just convert that for you with this RGB.color method. Okay? So next we jump into the void setup. So for those of you that are familiar with Arduino, this is basically the method or function that's first called when you first turn on your microcontroller. So what we're going to do is we're going to come into here and say RGB.control, give it a value of true. That means that we are now controlling the RGB LED that's built into the photon. Then we're going to have our client connect. This is where we pass in the name of the node. So I'm a huge fan of transformers. So this is SkyStream Photon. And then if the client is connected, then we will publish to the topic that it's joining the system, and then it will immediately subscribe. And then in our void loop, we just say, if the client is not connected, reconnect, and then client.loop. So it's just going to check to see if it's connected. If it's not, it'll reconnect so that we don't drop any messages.
You want to review that just one more time, please?
Hmm?
Can you go over this one more time?
Yeah, from the top?
No, from the setup.
Okay, so the void setup, so within the particle photon, there is there's basically a series of methods or a library that you can call that's always important for controlling the RGB. And so we call the RGB.control method, so that's a method underneath the RGB class, and we pass it a value of true. So that'll turn on the ability to control the RGB LED on the board for us. The next thing is then we tell the client or the photon to then connect to an MQTT system, and we pass it the name of the node. So if let's say you have 100 of these or something, you would want them to have unique names, and you want to check like, hey, when was the last time this node was on? There's stuff in there that you can do. And then we check if the client is connected. So the opposite of this is it won't do that. Then the client will publish to this publish topic called to the publish topic, which is hello world, and it'll say I'm joining the system. So I do that as a good way to verify that it's connected. And then it'll also immediately subscribe to the subscription topic, so the topic that we're going to be sending messages out. Then the next thing is we do this void loop. This is basically our void main with a while true statement. And we will loop over this indefinitely, and it says, so I've got an exclamation point, which is the inverse of the logic. So client dot is connected. So if it's connected, it will return true. If it's not connected, it'll return false. And if it's not, so if this does not reduce to a true statement, then I'll drop down in here. And it'll basically reconnect me. And then I just client.loop. So it'll just continue to go through all of this. You don't really need that client.loop. That's something for some more advanced type of MQTT stuff. You could really just take that out and it would still kind of run.
Well, no, you still need the client loop, so that it gives it time to process incoming messages.
Yeah, this is,
You still need it.
yeah, if you were publishing messages really, really fast, this is kind of a, while I'm not receiving them, or while I'm receiving a message, just wait until I've finished receiving that message.
Right.
Let that buffer stream fill.
Right. It won't work without it.
Mm-hmm. Well, you can, if you're publishing messages like once every second, if you go over like slower than a second, then it starts to fill up buffer streams. So here I basically have that same exact code here in this sketch. So the next thing that you'll do is you will click this flash button, and it'll say flashing, and it'll turn magenta, and then it says flash successful. So here I have a subscriber continually running. Let's close this thing and let's open it up. ls dim mqtt subscriber. For those of you that have participated in our other workshops, this is the Python. So this is what's running on my computer. I already have an MQTT broker installed, which is the MQTT Mosquito broker running on here. So I already have that, and then I also have the paho.mqtt library installed. Paho is kind of loosely developed by IBM. It's an open source thing, but they're like the major contributor. So Paho is one of the numerous MQTT libraries. So for information on how to go and get this stuff, please refer to our older Raspberry Pi workshop resources. So here on my computer side, I do this import paho.mqtt.client as MQTT. So for those, has anyone not ever done Python programming? Okay. So import is the same thing as pound include. So I'm just importing this library, I provide the path to it. The next thing that I do is, this is a comment, obviously. I declare a message that is, or I declare a callback for when the broker receives a message, so it's a subroutine. It says message received, and then it takes the payload of the message, converts that to UTF-8, and prints it out.
But this isn't Python, is it?
This is Python. This is a comment. So pound symbols in Python denote comments.
But I mean, didn't Photon take C?
Yeah, it does. So we were showing here is the C code that's running on the.
Oh, the server. Right.
Yeah. So this is running this is Vim. My text editor of choice.
Is in that usage then is pound defined actually a comment, or is pound defined the command sequence?
This is a comment.
Okay.
This is a comment in Python. So as you can see, there's pounds up here. The pounds in Python are comments.
But other languages, they're.
That would then denote a pre-directive.
Yeah.
So if anybody's interested in learning more Python stuff, I'm interested in doing another road to code thing with the focus on Python stuff.
Sweet.
So we define our message, or define our callback. So this is a callback called onMessage. So when we receive a message, just print it out. So on the broker side, or on the computer side, we create an instance of a subscriber. Well, we create an instance of a client called subscriber, and then we overload the method subscriber.onMessage with our own method, this onMessage, and then it'll just connect. Subscriber will subscribe to our hello world topic, and then it will loop forever due to this while reconnect is true. Subscriber.loop.
What is the RC stand?
Reconnect. So it's just a semantic that's used within the MQTT stuff. So if RC, so if this returns as false, then RC will equal 1, and it's just saying that this subscriber didn't connect. So it's just a variable that I'm using. But you'll see if you look at a lot of MQTT examples, they'll use RC as the reconnect variable.
I thought that was like return code or something.
Yeah, that's true. It is return code, not
More
return.
like return code.
Yeah, there are other codes. They're like a -4. Like if that's right. Fred's totally right. I'm wrong. It's return code. Because within MQTT, you can ping a client that's password protected. And it'll say, hey, I'm on the network and I'm running MQTT, but that's the wrong password. It'll return a different value, like a -4 or something.
Yeah,
Good
I
point.
think C and C++ kind of misleading because on success functions return 0 instead of 1. And they return 1 when something's wrong. You kind of think that would be the other way around, considering 0 is conventionally false and 1 is true.
Well, you can change this to whatever you want, because I'm just doing this comparison. But yeah, if success is a 0, it should be like a 1.
Yeah.
So, okay, so there's that. So here I don't have code, so here, so I will launch the subscriber. So now it's working. So here we've got this subscriber running. Let me restart my Photon so you can see when it joins. So I just plugged it into power, and so it already joined the system. Okay. Now the other part of that is it is running a subscribe. Right? We want to be able to send commands to things. So the Internet of Things is both the ability to collect data as well as send data to certain things. And I wrote something that I don't remember where I put it. So,
Locally?
yeah, CD Photon Publishing? Nothing.
Photon subscribe?
Oh, you know what? I have it running on my Raspberry Pi. At home, that's where I did it. So, let me go back into a previous workshop.
Can you FTP, is it online? You can FTP to it.
I don't have it online. And I don't have port forwarding turned on my router.
I was gonna say, otherwise you could call the wife and have her plug it in.
Yeah. She is at work.
Oh, honey, can you? Yeah.
Oh, here we go. Photon fast publish. Okay, so let's go into. Here we go. So here I wrote a publishing client in Python. So this is what's running on my computer. What this will do is send commands to my particle photon, and my particle photon will receive the message and then do something based upon whatever that message is. So very similar syntax and structure. I import paho.mqtt.client as MQTT. Then I also import time. C, it's C time, right?
I think so.
Yeah. Basically, this will just allow me to interface with my clock to be able to get timing stuff. I create an instance of a client called publisher. This publisher then connects to my computer. Let's change this to localhost. So it'll connect to the local host. Same thing, it'll join the system. And then it'll publish to a topic called color. I think I changed it in here, colors. Nope, color. It'll publish to this topic called color. So it'll say red, and then I'll wait 5 seconds, and then I'll go green, and then I'll wait 5 seconds, and then I'll go blue, and then I'll wait another 5 seconds, and then loop back. So this is just a proof of concept to say, hey, am I doing this right? So let's do a source activate IoT.
Spelling.
Anybody ever watch the Wonder Twins? Wonder Twins activate. No.
Watched Wonder Years.
I've seen Wonder Bread commercials.
Okay, so here you can see that my, so it said red, now it's green. Let's wait 5 seconds, go blue. So here I'm sending commands to my photon. As you can see, there are no USB cables connected to my computer. This is just power. This is where the woman is floating on the table, and I take the and everything. So here we've just written and built our first communication to our photon, sending and receiving information. Alright, so we'll take a quick break. I'll get a drink of some water, and then have you guys do the same thing for those that have hardware. For those that do have hardware or don't, feel free to ask questions, and etc.
And you don't mind this using your MQTT server? I mean,
Nope.
it should.
Nope, so yeah, if you subscribe to this, you'll notice that yours will start changing colors. So for those that need the IP address of my my MQT or to my system, ifconfig. It is listed here at 10.11.17.140. Now, one thing to note, that if you take a look at the Python code, let me create then MQTT subscriber. Because this is running on a computer with an operating system, I can do things, I can cheat, and I can pass in variables like localhost. Whereas in C on the Arduino and the Photon, you have to provide explicit IP addresses.
And also, if you could mention the MQTT server on austinIoT.com.
Oh yeah, do we have an IP address for that?
You can get it through a nice lookup. It shouldn't be that hard to find.
Okay, so for those of you that want to contribute to some crowdsourcing of data collection or want to be able to be pushing data to an actual online server, Dave Brixius and Dave Fowler set up an MQTT server running on AustinIoT.com.
And that IP is 52.33.179.176. 52 dot
52.33.179.176.
33.179.176.
Do we know what port it's listening on?
It's on 1883, and we also have it set up for WebSockets connection on 8883.
88.83?
Yeah.
Okay.
I can't get either of my photons to work.
You know, I was having a real tizzy of a time earlier too.
Is there like,
Okay, so welcome back everyone. Hopefully you're enjoying some pizza. We took a little break. So for this next demo, what we're gonna do is, so far we've demoed how to send commands to the particle photon. Now we want it to read from a sensor. In our case, we're gonna be using these door switch sensors, which are just Hall effect sensors. So the way they work like in any security system is, yeah,
I also have a couple extra of those if anybody needs one.
okay. There's a magnet in here which will then hold open the switch. When the magnet's released, it holds it closed. When the magnet's released, it opens the switch. This is very similar, pretty much exactly the same as what we did with the Raspberry Pi, using a digital read system or setup. So what we're going to do is you'll take a couple jumper wires and you'll power your ground and your positive voltage rail next to your photon, or you can just directly go to the power rail. But on one side of the switch, we have it connected to the positive 3 volts that the photon provides out. And then the other end, we have it just connected to a digital switch, or a digital pin. And so I have it so that the LED will write a red when the door is open and blue when the door is closed. But then also, it will publish a message to an MQTT broker that the door is open for the duration of the door being open. Later on, we'll write it so that it only detects it on the change of state. So it'll only publish once, but like all good programs, they have to start somewhere. So if anybody needs any help with wiring or anything, let me know. These Hall effect sensors, you can get them like a dozen of them for like $5 on AliExpress. So they're pretty cheap, and the impetus was like, hey, I want to build my own security system. So get text messages to my phone or something. So here is the code that we are running on the particle photon. Very similar to the color control one that we were doing earlier, other than the fact that we changed our publish topic to doors. Now you could add depth to this, so like let's say you wanted one for door 1, for door 2, for whatever. You just separate each of those subcategories by a /.
Now, I thought instead of server, you said had broker there before.
Yeah, it's just the name of the variable.
You're not, no reason.
Yeah.
So can we use the same photon for different nodes? Or do we need?
If you ran the Hall effect sensors to them. So, so for this, you would probably only have just one photon per door because they would just be sitting in like. So the way that I'm building mine is it's just going to be a little 3D printed box that'll be on the top of my door, and then I'll run power to it somehow and figure that out, whether it's batteries or something.
So it's only one door at the moment.
Yeah, yeah, one microcontroller per door. So I have a version of this that runs on the Node MCU, which is a Wi-Fi microcontroller that's a lot cheaper.
And you're calling yours SkyScream or something,
Starscream, yeah, SkyScream,
SkyScream Photon.
yeah.
So we have to use our name instead of your name.
Yeah, yeah, well, you can still use the same name, it would just show up as the same node, which would be confusing if I looked at the node names. Okay, so same code as before, we've just changed our publish topic. The next thing that we've done is we've declared what pin we're going to read from. So we've just created this variable called door pin. It's a constant integer of 3. So when the compiler goes, it'll replace all the instances of door pin with 3. We still have our same callback. Yeah.
So on the door pin equals 3, so that's an input, I got that. But so is that by default, or do you have to tell it it's input pin?
So you tell it what it is. So I'm using digital pin 3.
Right.
So you'll just put in whatever number for the digital pin that you want to use on your microcontroller.
Right, but on the microcontroller, isn't the pin IO, so you can input one output?
Yeah, so later I define it as an input.
Okay.
So this is just creating the variable name, so I don't have to type in 3 every time I want to talk about pin 3, it's just the name door pin.
And these Hall effect sensors, like, so one pin is ground and the other one is input?
There's no ground.
Yeah, so one pin connects to a power source, so a voltage source, and then the other pin will then connect to the input of your microcontroller.
There's no polarity.
So here is actually where we start to declare certain things. So here I took the RGB control part, and then I use this directive called pin mode, and I provide it the name, and I tell the microcontroller it's an input.
And you don't pull it up or pull it down, it's just a bare input.
Yeah, just a digital input. Yeah.
The reason he assigned the number 3 to door pin above was that in case he ever wanted to change it, then he only needs to change it in one place.
Mm-hmm. Yeah. So I could then just call the variable door pin. Or if I wanted to do something else with that in like a function or something. So then it's the same stuff as before. But here in the void loop, I've changed it so that it will, so if it's not connected, it'll connect. And then I get to this next if statement. So if digital read of door pin is low, meaning that it's not connected to 3.3 volts, it will then read as a high. Or if it's reading as a low, it'll publish to my publish topic, door is open, and then it'll write 255,0,0,0 to the RGB, so turn on the red part of the LED. If not, then it'll write blue to the LED, meaning that, hey, everything's copacetic, and then I open the door, and it's writing the red part to that LED.
Could you hold that up again, Cameron?
Yeah.
Now, don't you have to take control of that LED? Oh yeah, RGB control, line 41 is critical.
Yeah, of taking control of it. So this
Yeah.
RGB.control,
Okay.
where you're passing the value of the true to it.
One thing you could do is set it like set the color and then set a delay of 1 second and then return the control as false. If you wanted to, as an alternative, that works.
Yeah,
Just have a dumb question, but, you know how if you're detecting an input, how you can detect it like one of two ways? One is you can pull the pin, and then the
Mhm.
other is you handle it through an interrupt. Is this, which one of those is
this is polling,
Okay,
the inefficient way.
alright, that's what I thought, I just wanted to make sure. Okay.
Yeah. So yeah, that is something we'll probably cover next time is interrupts, creating our own interrupt service routines, which we did with the Raspberry Pi. But yeah, so this is, so for anybody here not familiar with polling versus interrupts, so polling, one way to think of it is imagine that you're waiting for a package to come. It's like you just ordered a new phone and it's supposed to be arriving that day, and you don't have a doorbell. So every couple minutes you go to your door, open it, and see if the package is there. It's not, then you go back upstairs and continue to work on stuff. And you do that every 5 minutes. So that's polling. It's for certain things it's very inefficient, but it's a really good way to, like if you want high precision. The other way is what's called an interrupt. So that's like your doorbell. So you're sitting there working, delivery guy rings your doorbell, oh, something's here, you stop everything, and you go and check the door. Yeah,
Now, does that work the same if what you're waiting for is a case of PBR?
yeah,
Right?
yeah. Okay, so shall we, do you guys have this working? Yes, Steve?
How do you guarantee that it's low and not floating?
That is a good way. I'm not doing anything to check if it's floating or not. One way is that you could have like a pull-up or a pull-down resistor.
I was
As
gonna
part of
say
it.
that.
Or input pull up when you define the digital setting. So back up the line.
Does Photon support
Yep.
internal pull-ups?
Yep.
Oh, I didn't know that.
So line 45, you could say input underscore pull up or input underscore pull down.
Okay.
Good answer.
So in that case, you want to pull down.
Mm-hmm. So in fact, let's do that right now. Was it all caps?
Floating
Yes,
higher or low.
input underscore,
Yeah.
input
When it's
underscore,
open,
pull up or
it
pull
can
down.
float higher or low.
Input underscore,
Just on the
And you have to put it either pull down or
underscore,
and then longitudinal.
pull down, just all one word.
either one, yeah.
Let's reflash that. So, disclaimer, I'm not an expert on anything. I just provide the information that I have to hopefully empower others.
And you do a good job.
Indeed.
There we go. Why is it? Oh, wrong subject. Wrong topic. No. Where's my door open one? Oh, you know what? I don't have it running. There we go. So, open it. Oh, there's nothing else on there, so. Control Z. We'll rerun that. Okay, so it's running. I'm gonna connect. Oh, and it populates a whole bunch of messages real fast.
I guess because each time it goes through that loop, it pushes a message, right?
Yeah,
Okay.
because I don't have any variables of saying like,
Like
oh,
state
did a
change,
state change
yeah.
or anything like that.
Okay.
It's a very simple, hackerish.
Excuse me, Cameron, is anybody gonna have more pizza?
I'll grab a slice.
Which one?
I don't know. Pizza one?
I think this guy.
I'll grab a slice.
Okay, any other questions? Okay, we'll take another quick break for those that are building this, to give them a chance to test it out. It's not that action packed, because it's gonna be a little bit of live coding, since I haven't done a sketch with interrupts on here. Door. Okay. Let's take,
But I don't think so.
that's,
The IoT.
bring it over here. Okay, so we are going to change this guy, if I understand the documentation that I read real quick, to attach an interrupt. Okay, so we still. Okay. We actually don't change it, we just add this method. So. Attach interrupt, so syntax, yeah, attach interrupt. Then we link it to the pin, which is the door pin. And then we link it to a function, so we'll call void, link it to, say, door open,
It's open.
door function. And then, we want it, when it changes states. Capitals. Okay. So now I need to create this function called void door function, which doesn't take any arguments, but it'll do a client.publish to my hub topic, saying that door is open, or door state change. We'll have to go back in and write some if rising or if falling edges. Okay, now let's just take all this guy out. RGB color T55, comma 0, comma 0. Semicolon there. Okay. Verify you. Save. to their void loop. Did I spell that correctly? My photon's not working. Power cycle it. Flash successful after I power cycle it. There we go. Okay, so join the system. It's not triggering my interrupt function. So this is the problem with live coding and reading documentation. Oh! I'm not, no? External interrupts are supported on the following pins. Digital 0, 1, 2, and 3, and I'm using 3.
Three.
That's not all of them, is it?
No, but photon all pins with the exception of D0 and A5 since present mode button external interrupt. Wonder if I change the syntax to be D3.
D0 or 3?
Well, I've got my I have my Hall effect sensor connected to D3. Oh, D3 cannot be used in correspondence with the digital to analog converter, so let's change that to D4. And I'm also writing to the LED, which would then be using the DAC.
Maybe we defined it in one spot.
Mm-hmm.
So everything's compiled server side, is that right?
Mm-hmm.
So if you do an include for MQTT,
Mm-hmm.
are the libraries stored on a server, or do you need a local copy library, or?
Their links are stored locally on the server, but they actually have some really fancy Node.js stuff that's going in the backgrounds and connecting to GitHub repos.
Okay, understood.
Node.js is awesome.
Yeah, it says that's connected. It was not successful. You lie. let's try it anyway. Yeah, it's not reporting any state change. See. Okay, join the system, but it's not reporting the state change of the pin. So I apologize, I will have to look into why it's not calling my interrupt function.
You also need to set the priority.
It's optional.
Yeah. So here, where I call my interrupt, my attach interrupt, and my void setup, I pass it the interrupt pin, function to call, and it's mode.
Is it pull up or pull down still? I'm just kind of curious how you did the input up there at the top.
It would be pull up.
Good.
Now my photon's not flashing. Says it's ready. Try it again.
Does it have power?
Yeah, it's got power. As if I power cycle it.
Sound, wow.
Be sure to switch is good.
Was earlier.
Yeah, well, it says it joins the system when I first connect it, which is my little verify that everything's copacetic. Here, watch, it'll say join the system. See, joined it. So it's connected to the network. Let me refresh my reload. So let me now if I reflash, in theory, it should rejoin the system, but it doesn't. It says that it's offline. Somebody take control of my photon.
No.
Messing with
See? But particle is not seeing it. So it's not connecting to the outside world.
We'll comment out the interrupts. I mean, you can start backing out code.
It's true.
flash unsuccessful, request timeout.
Kind of a stupid suggestion, but do you need the interrupt in your loop?
Yeah,
So
that
that's
would
what
be
this function interrupt said, according to the documentation.
Yeah,
Huh.
that's a weird one.
Cause yeah, I'm looking at some other examples and they don't have that in their loop.
Yeah, 'cause otherwise aren't you polling or interrupt control?
Yeah, that's what I'm thinking. What if you comment that out and try it again?
Or put it in seven,
Did,
or attach is always seven.
Still just not flashing though. Disconnected. Let's go back to the real basic. Let's go to Blinky.
Is Blinky set up for D3 or D4?
It's actually using D7, which is another pin that's on there that has just a blue LED, but that's not even working.
You wanna try, wanna try a different photon?
Sure. I think mine's deep, Jim. It's deep. Because if I hold down the setup button, I'm not even getting the flashing. It's totally deep, Jim. But if I hit reset, we'll go through that. Oh, you know what? The challenge is if I link this one to my Photon account, it'll be linked to my Photon account. Like, I guess I could remove the device afterwards. It's totally deep, Jim.
That's not gonna bother me any, I just factory reset it then.
Okay.
Unless it'll cause you harm.
No. Add new device.
I factory reset it every time I plug it in. So.
Yeah, this one's not showing up as a price. Let's try to model that. Is this one called Stars Drip Down Like Butter?
What's that?
Is this one called Stars Drip Down Like Butter?
It may be. They give me a different one every time I reset it.
Does it have a password?
It shouldn't. Is it saying it does?
Yeah.
Can you factory reset it?
Was that just hold down the reset button?
I think it's, isn't it rehold, or hold down both of them?
No. Somebody's got stars stripped down like butter though.
I think this one has a YD dash something.
Mm-hmm.
You have something that starts with a Y.
No, I'm not
That's
seeing.
what I did, and then I'm able to figure, like configure it after that.
Mhm.
Uh,
See if this one will come back online. Okay, so it says that it's not connected.
I got the directions for factory reset if you want it.
Yeah, is it just hold down both buttons?
It's hold down both buttons, release only the reset button while holding the mode button down. Wait for the LED to start blinking yellow. The LED will turn solid white. Then it will blink white rapidly, and then you release the mode button.
Okay, so I keep on holding that one. So it's blinking yellow. Do I have to like sacrifice the server or something?
I shouldn't.
So when it's blinking yellow, I keep on holding down the setup button, right?
The mode button.
Okay.
And then it just, the next step says the LED will turn solid white. Continue to hold the mode button. Then it'll blink white rapidly, and then you release the mode button.
This is yellow, right?
Yep. Didn't turn white. Is that yours or mine?
This one's mine.
Let me see if I can get mine reset to factory. Hey, David. Yeah. Is that yours or mine? Yours. Okay. How much altitude do we have left, and how far away is that mountain?
I don't know. Yeah, I think mine's dead. I don't know. What do I do to kill it?
So you take out the inner stuff.
Well, I can't even reflash it now. Just stuck in this perpetual locked mode. Let me disconnect everything.
Or the token, maybe the token expired or reset or.
It's connected just to the power source.
Possibly the site's down.
That could, well,
It was just working a second ago.
I can verify code.
Yeah, that factory reset isn't working over here either.
Wonder if it's something with Tech Shop's Wi-Fi. Fred, are you still connected to yours?
Yeah, I'm flashing, yeah. I just pushed the flash button from the server.
Uh-huh.
And let's see if it's connected. I'm sure the device is blue, yeah. Device connected. But there's this other, what's this other one? The settings. So if you go into settings, you can reset your access token, or you can clear. You can reset the token.
Excuse me.
Bless you.
Oh, not bad. I think I'll run to the restroom to take care of this sneezy nose.
No,
So you should be able to remotely connect to a photon that doesn't belong to you, but it's a password that you need for it, right? Is that a certificate or is it a password that they use for that?
I think it'd be a password.
Something about the,
Does anybody use these for like industrial applications?
Not yet.
Okay, like,
Recently they got a new,
Cameron, do you use these for industrial applications? I don't know, like.
No, I
pretty
don't.
high resolution.
I know there are certain products people have built on top of them though.
Do you know a good website that sort of showcases that stuff? Or?
They do on their website. They have some things. They're
It's cool. I can look it up. But I'm just curious.
They have a cellular product too.
Really?
Yeah, Photon's Wi-Fi, but they have a cellular one too.
I'll try that later. What do you
Same
think?
thing on the cell network.
Another question I had was sort of like for the IoT group in general.
It's not IoT.
Is like there's so many things that you want to connect wirelessly. Wi-Fi is sort of the data backhaul of choice if you have it. If you don't, cellular is a good option, but you need a SIM, right? Like, has anybody created a backbone that doesn't require a SIM and you can pay on like a like per kilobyte or transfer or something like for IoT devices, like sell for IoT? Like, does that exist or?
So certain devices you actually don't need a SIM. Like you can use an older, not the SIM. What used MEIDs? It was like WiMAX or something. There are other cellular data networks that are still in use that you don't need like a physical SIM card. You just have to register like the MEID device, which is similar to the MAC address
Right.
for that. So there are things, and there are companies out there where you do pay for the amount of data that you use, but they're really small and they're typically regional. There's nobody that's really done anything that's national that I know of.
What about Lumix?
Hmm?
Lumix?
Well, they don't provide data service, they just do data management and data analytics. But like an actual managing of wireless devices on a cell network, I don't know.
And what about the Things Network?
Hmm?
What about the Things Network?
I'm not familiar with that.
For the municipal area, the wide area,
So Laura went,
law,
Mhm.
yeah. They use those services,
Mm-hmm.
especially for low bandwidth.
Yeah.
Mm-hmm.
That's right, I don't wanna derail the conversation, I'm just curious.
No, I think we've kind of hit an issue. I can't reflash it. Huh?
Yeah, that's
So I guess,
Do you wanna try another particle? You don't
well, is it linked to your account at all?
wanna, I didn't set it up.
Yeah, to have like a data back.
There's a stand for that.
Yeah,
Asset driver data.
It's
They
really set
come
it
with a
up.
3-month data plan.
Okay, well, try that.
They still need the data plan.
I see, right,
That's part of the part. So you can create like a GPS device
right,
that still uses the SIM and
yeah,
to communicate with the
yeah,
cloud.
yeah, I'm curious to see.
Well, you
what-
demonstrated what you intended to demonstrate.
Right, is that
Yeah.
you're going to have focus of energy on the router, and then like client-to-client connections. I'm curious if that's going to be a thing that will happen or not. But I think I discussed it with the guy within the IT group one meeting when we were over at the Franklin's Pub, doing client-to-client connection, or also like subleasing off of a cellular device that had a Wi-Fi hotspot. You know, like you would. A device that connects to your Wi-Fi on your phone, and then you would essentially generate revenue from that, per KB basis, for calls. Low priority, low bandwidth data backhaul.
The GPRS is big for the case. GPRS is one which is sending the data for like a DC match. That's dependent on the GSM. Oh. So you need GPS device.
Another thing we didn't demonstrate is like the dashboard on Particle. You can publish
Data has to be sent.
messages to their dashboard as well.
Mm-hmm.
Vehicle navigation, and that, does that have a setting?
No, it doesn't.
It's
It's
just
just
a one-way communication.
It's like a sensor which is getting data from the GPS satellite.
That's what I thought.
So yeah, Particle, another thing that they do provide, they have a dashboard where you can publish data to. It's very similar to Adafruit's. So Adafruit has built out another MQTT service which you can publish your data to and then access it. However, depending on the data that you're collecting and everything, you may not want other people to be having your data or something, because you don't know what's going on with it. Okay. So it's not allowing me to set it up over my phone.
So you're gonna do with the particle CLM? Is that what you're gonna do?
Yeah, that's what I'm trying to do, but.
bless you.
Something in here?
Yeah. this one, I think you already have this one linked to your account. Do you know if you have that, Glenn? Did you set this one up at all?
Yeah, it did, it has a name on it, but you can reset it.
Let's see if I can have to reset this one.
I haven't flashed it or did it, downloaded anything on it.
Okay. Green. Oh shoot. Okay, there we go. Now it's white. Uninstall the app. Go and re-get it.
Oops.
Ah. Okay, I can't set this one up because I just got a new phone and Samsung. Yeah, it might be. So, Glenn, you have the new S7?
Yeah,
Do you know which version of Android it's running?
I just updated it, it just went updated today. And under settings. Yeah, under help.
I think it's under General Management. I've got Android 6.0.1.
Six dot zero dot one.
Oh. Yeah, because when I search for devices.
No, I just loaded particle on this,
Uh-huh.
so it's a brand new particle.
Do you mind if I see your phone?
Yeah. So you can connect to it if you want. It's running this right now. Let's see.
Yeah, yours sees it, mine doesn't.
Try clearing your cache.
I was having this problem with
Yeah.
my S6. It wouldn't connect to it. It would see it, but it wouldn't connect to it.
Yeah.
And my S7, it's connecting.
That's wild.
Very
Okay.
wild.
Have you tried, Cameron, have you tried clearing your cache on the app? Or-
Yeah, I got it.
I just uninstalled it and reinstalled it, and now I'm power cycling the phone.
I think with Androids that doesn't clear the cache. I might be wrong.
Power cycling or
Power cycling, even uninstalling and reinstalling, it'll keep like, it's like your, you know.
So go to the application
like,
manager
user,
and
you know,
just-
it like
Uh-huh.
keeps it even when you uninstall the package. If you
Ah.
reinstall that package, unless you do like a clean,
Uh-huh.
so, I'm
Okay.
just guessing.
And I just read that factory reset is not available on Photon P1, but do not worry. If you are experiencing problems with your application firmware, you can use safe mode to recover.
That sounds like a fun option.
Yeah.
Sounds safe.
Don't worry.
Yeah, don't panic.
Don't panic.
So it's not with your photon, it's with the application that you're running it
Yeah.
on. All of a sudden, it's not working.
Mm-hmm. Ooh, hey, it's frozen on. Wait a second. Wait a second. What's going on?
Flash.
Stuck on a red light.
Flash. See if it's connected on the web.
Well, I removed the device,
Oh.
so. Okay, so let's,
Playing.
you're under settings. Device maintenance.
Can you run a web server on a Firewall?
Yes, you can.
Tiny,
Okay.
tiny. One Python.
Yes, a very small one. Okay, so cleared up the cache.
How do you clear the cache?
Under device management and then under RAM. Okay, so we'll do that. Sorry to be such a downer, you guys. We're experiencing some technical difficulties here. Please stand by. Thanks for calling IT. We turned it on and off again.
Number one step, right?
Yeah.
Well, and I guess another thing with the interrupt handler is you don't want it to bounce either. I mean, if it's gonna bounce into the routine, you probably need to turn off interrupts within the routine that you're
Mhm.
processing. I mean, I think that's pretty fast code, but you should handle the case where
For debouncing.
multiple, debouncing or jumping into the routine again, another interrupt, jump into the routine again. It could be, out of stack or whatever.
Mm-hmm. That makes sense.
So good code would turn off that interrupt when you're in the interrupt
Mm-hmm.
and then do whatever length you're gonna do and then jump back. Or relay to it and jump back or
Yeah, so it's not interrupting the interrupt.
Right.
Doesn't, when you jump into an interrupt, doesn't it stop everything else?
Well,
Cause you can't even like connect to the clock or anything. Well, you can't keep good timing when you're in an interrupt, cause it's basically stopped the clock.
or other interrupts, yeah, it should, you'd think, yeah.
Well, this is in a perpetual state of fail. So,
Do you have your Python script on your gear?
huh?
Do you have your Python script on your gear? I didn't see it.
Excuse me. Let me double check to see if it is. I think I pushed it there just a few minutes ago.
Okay, cool. I haven't checked it since then. I was checking.
Yeah. Photon publish, photon fast publish. It's the same thing. It's just half a second for each of them. And then there's the MT